In question 1b, use the diagram to determine 1b1. Use the diagram to determine the distance between the time 3 seconds to 6 seconds. So for a time interval for 3 seconds or from 3 seconds to 6 seconds, you have to check. This is the time interval 3 seconds. And this is the time interval 6 seconds. So what it is making a trapezium. Area under the graph for speed time graphs give the distance traveled. Or what else you can do? You can divide this into a triangle and a rectangle. So find area of the triangle and area of the rectangle. That will give you total distance traveled. So area of this part, the triangle, it will be half. It is starting from 3 and ending till 6. So that is base is equals to 3. And height, this value, each is on y-axis, each is representing 0.2. So this one is 5.2, 5.4, 5.6. So it is starting from 5.6 and till 11. You can use a trapezium or you can use a triangle plus rectangle. So starting from 5.6 and it is ending at 11. So this height of the triangle, it will be 11 minus 5.6, which is equals to 5.4. So that is the area of a triangle. For area of the rectangle, it is length into width. So length is 3 and the width or the height, that is equals to, sorry, the triangle is starting from this point. I thought it was 5.6, but it is starting at 5. So from 5 to 11, so directly it will be 6. And here that is equals to the 5. So 3 multiplied by 5, that is 15. And 3 multiplied by 6, 18. 18 divided by 2, 9. And 9 plus 15, that will give you 24. So the distance traveled will be equal to the area under the graph, which is equal to 24. If the speed is given in meter per second, distance will be in meter. If speed in centimeter per second, then the distance will be in centimeter. The second part, B2, the deceleration between the time 3 seconds to 6 seconds, because it's a constant deceleration, it's a straight line. So what you can take a gradient within this, because for straight line we can find the gradient. And how to find the gradient? The formula for finding a gradient, that is y2 minus y1 over x2 minus x1. You can use a gradient method, you can get the answer. Or you can find an acceleration which is v minus u over t. For a straight line, gradient method and the equation both are valid. But for curve, only gradient is the method. You cannot use a formula. So this is the starting speed, which is 11. The final speed when time is equals to 6, that is 5. And the time interval, because it started from 3 and ending till 6, so the time interval is equals to 3. So 11 minus 5 divided by 3. So 11 minus 5 is equals to 6. And 6 divided by 3, that is equals to 2 meter per second square. That is the acceleration of this object. Any doubt in question 2? Is there any doubt in question 2? Question 3, is there any doubt in question 3? If you don't have any doubt, just type no, so I will move on to the next question. Question 4, is there any doubt? Question 5, is there any doubt in question 5? Question 6, is there any doubt in question 6? 6b. In 6b, figure 6.1 shows a ray of a light incident on a glass block at A. So you can see it is incident on B. And it is refracted when it moved from air to glass, it bent towards the normal. The critical angle of the glass is 41. On the figure, without calculation, continue the ray from B until it leaves the glass. So basically, if I draw a normal here, what is the angle of incidence at point B? So the angle of the incidence at point B, what is angle of incidence at this point? Angle of incidence is the angle between the incident and the normal. So what is the angle of incidence? So angle of incidence is 60. So if angle of incidence is more than the critical angle, then we will have total internal reflection. So instead of light will go out, it will bounce back or reflect back in the same medium. So it will follow a law of reflection. Then if we draw a normal at this point, normal is always perpendicular or 90 degree to the surface. Now this angle is 60. This will be 90 between them. So what will be this angle? Because the total sum of angle of any triangle is 180. So 60 plus 90, so this should be 30. So if this is 30, what it shows? It shows at this point, if I say label this as point C. So at point C, the angle of incidence is 30, which is less than the critical angle. If it is less than the critical angle, then we will observe a refraction. And refraction means when the light travel from glass to air, it will bend away from the normal. So this will be the path through which the light will. Because if I draw like this, it means bend towards the normal. If I draw straight, means no refraction. And if I moving from glass to air, the speed of the light increases, so it will bend away from the normal. Is it clear? And the second part, calculate the refractive index. So how to calculate a refractive index from the critical angle? The formula refractive index is 1 over sine C, where C is the critical angle. So it will be 1 divided by sine 42. You will get the refractive index, which is 1.5. Question number 7. Is there any doubt in question 7? 7 part B, the sound wave travel in air towards the barrier with a small gap. So this barrier is having a small gap. State what is meant by compression: the region where the particles are closer and the pressure is high. The width of the gap is smaller than the wavelength. On figure, draw a pattern of the compression. So when wavelength is smaller, width is smaller than the wavelength, then maximum diffraction. So what we have greater spreading of the wave. This is how we draw. When the gap size is smaller than the wavelength, that time maximum diffraction occurs. Question 8. Is there any doubt in question 8? 8B1. Explain why the galvanometer deflect as the bar magnet is inserted in the coil. So when the bar magnet is inserted in the coil, there is a change in the magnetic field. Because the idea is that even you move the magnet towards the coil or you move the magnet away from the coil, so movement of the magnet will produce change in the magnetic field. And what is the effect of change in the magnetic field? Change in the magnetic field will induce EMF. Question 9. Is there any doubt in question 9? In 9B1, you need figure 9.1 shows a 6-volt battery which is connected in series to a 1.2 kilo ohm resistor and a thermistor. At a certain temperature, the resistance of a thermistor is 2.4 kilo ohm. Calculate the reading on the voltmeter. So for this we can use a voltage divider formula, or what we can do, first we can find the total current in the circuit, and after finding the total current in the circuit, because the two resistors are in series, so they will have the same current, and using the current and the resistance we can find the voltage. So there are two ways. First you will find the total resistance. The total resistance will be 1.2 kilo, so means 1.2 into 10 to the power 3 plus 2.4 into 10 to the power 3. So the total resistance of the circuit will be 3.6 into 10 to the power 3 ohms. That is the total resistance of the circuit. Then if we need a total current, we have the formula V is equals to IR. V is 6, I is a current which we don't know, and R is a resistance, that is 3.6 into 10 to the power 3. So 6 divided by 3.6 into 10 to the power 3. 3.6 exponent 3 means 3600. So 6 divided by 3600, that will give us the total current, which will come out to be 0.0016 ampere. 1667 is there, so 0.0016 ampere. Now we know, because they are in series, so they will have the same current. So we know the current here, we know resistance, so we can find the voltage. Again, we'll use the same formula. V is equals to IR. I is the current, which is 0.0016, and R is the resistance, that is 2.4 exponent 3, or 2400. So this will come out 4 volts. So the reading on, and the voltage at 2.4 kilo ohm resistor is same as the voltage across the voltmeter. This is one way. There is also another short method, which you will use a voltage divider formula. In a voltage divider formula, where two or more resistors are connected in series, so what we can do, we can use the formula. If I'm finding a voltage of this one, so V1 is equals to R1, the resistance of that part, divided by sum of the resistance of the circuit, multiplied by total voltage. If I'm finding V2, resistance of that part divided by sum of the resistance, multiplied by total voltage. So that using a voltage divider I can directly find. So this already they mentioned, it is 2.4 kilo ohm. So resistance is 2.4 kilo ohm, or 2.4 into 10 to the power 3 divided by 2.4 into 10 to the power 3 plus 1.2 into 10 to the power 3, and into combined voltage, that is 6, the total voltage. So 2.4, when you solve this, again you will get the final answer as 4. So you can use a voltage divider formula, or first work out the total resistance, then the total current in the circuit, which will be same as the current in each component, and the current in each component, after knowing that current, multiply by the resistance of the component, you will know the voltage across that component. Is it clear? Question 10. Any doubt in question 10? (10b2). Describe the action that must be taken to obtain an even distribution of the positive charge on the sphere. So we want to make it positive charge. When we bring a positive charge rod, so one side it will be positive, the other side it will be negative. Then what we should do, we should connect an earthing wire. When we connect an earthing wire, so electrons are forced to go out, and majority of them are positive charges. We should remove the earthing wire first, and then the charge rod. Is it clear, B2? How we can make it permanently positive charge sphere. Question 11. Any doubt in this? 10 B1 and B2. In B1 we'll draw a positive charge top and negative charge down, and we connect an earthing wire. So connect an earthing wire, the answer for this, connect an earthing wire, remove the earthing wire first and then the charge rod to make it permanently positive charge. In question 11, a radioactive source is tested over a number of hours with a radiation detector. The readings are shown. Use the reading to suggest the value of the background and determine the half-life. Value of the background, because at this point the reading is not changing, approximately same. So you can conclude that if the reading is same, it means there is no not from the source, it is from the surrounding. So the background count, approximately when you take an average, it will come out to be 20. Now the detector reading is source plus background. So the reading on the detector is equals to source plus the background. The reading on the detector is 324. The background radiation are 20. So the source radiation should be 304. That's why the detector is recording 324. But after half-life, after first half-life, it will turn into 152. This will be 20, so the detector reading will be 172. There is no value given of 172. Then after another half-life, this will be 76, 20. So this will be 96. So it means how many half-lives are there when the detector reading changes from 324 to 96? There are two half-lives. And what is the duration for this two half-lives? The two half-life duration is 1 hour. So if two half-life duration is 1 hour, the half-life or one half-life will be 0.5 hours. Hydrogen has one proton and two neutrons. So if it has one proton and two neutrons, so this will be 3, because 2 plus 1, the atomic mass. It decay by emitting out beta. So if it is emitting out beta, it will be 0 and minus 1. Atomic mass remains same, and atomic number in a beta decay increases by 1. So that is the equation for a beta emission by isotope of hydrogen. Is it clear? So this was May June 2017, paper 4 variant 1.